yesterday we introduced related rates. Today we're going to keep on doing examples. I'm trying to make a verb out of it all day. We're going to keep on doing examples. Guys, look at the backboard real quick. Homework 29 on related rates is now due when? Tuesday. Why? Because we're going to do like lots more book problems tomorrow? No. But because instead we're going to do AP FRQ practice tomorrow, and it's going to be somewhat on related rates. So I'm like, all right, I can extend the deadline just a little bit.
Yay,
okay?
Thank you.
But. You need to start working, because if you leave it all till Monday night, you are going to hate life. All right, so notes open right where we left off yesterday. We had the oil spill. Guys who love to write paragraphs, okay, you don't really love to, but you just don't know how to not to. Hopefully my modeling of how to take a problem and shorten and sweet it to put on your paper is helping a little bit. We left off yesterday with, not that one, ooh, steps, they're good. Not that one, not that one. Why was he so stinking easy? Or should have been?
Because they gave us everything.
They gave us
like what? What'd they give us?
They gave us
They give him the find, the relationship, just
Everything.
take the relationship. We had to still rate it though, right?
Yeah.
What do I mean? We still had to take the derivative with respect to time and then plug in, and solve. Okay? Did we finish? Oh, we totally finished.
Yes.
Were there two different ways of doing it?
Yeah.
Yeah. Do they both work?
Yeah.
Why did I show you the alternate methods? Because some of you guys right about here wouldn't really keep looking back to the given and the find. You just say, hey, cool, relate it, rate it, take the derivative, and you're over here somewhere and you're like, oh, crud, that's not what I wanted. So I gave you a way to say, ooh, but it still could work if I find a different relationship and I rate that as well and then plug it all in. But we're going to move on. Ooh, we start right away with the ladder. Wow, you guys try to set it up, and some of you have already had some practice. Most of you have not. Anybody with sweatshirt or t-shirt money? Anybody with sweatshirt or t-shirt money? Come on back to my desk now. Okay, just some public humiliation for those people. Okay. Just kidding, not that bad. You guys are reading. You're drawing a picture. You're making up labels to use. Trying to relate it. Trying to rate it.
Yeah, no, because I had it right.
Oh, What is it doing? The ladder. Is he changing height as he's going down? No, so I don't have to label him with a variable. I can label him with a constant. I'm not labeling him with a variable, even though the ladder is going down. So this side's going to be changing and this side's going to be changing, but I can label him because that's constant. Now hold on. What do I need to label with variables?
5 feet.
Is 5 feet always true?
No.
So I'm not labeling anything with 5 feet, but what is 5 feet talking about? That's changing, and at some point it is 5 feet. Top, above, this one, it's changing, so I'm making him a variable. But by them giving me 5 feet, they're hinting that this measurement is somehow important to the problem. What other measurement are they talking about? The foot moving away. The rate of what? The foot moving away? The rate of this changing. That's how you know what you need. Now what if they said something like 5 feet above the ground and the rate of the angle changing? I wouldn't care about y. What would I care about instead? Theta. Can I relate with theta? Sure. In this case, if I took out the y and did theta instead, opposite hypotenuse, sine of theta equals, I can take a derivative of sine. The units get really messy really quick, but I can take a derivative of sine. But in this one, they didn't say angle. They said foot slipping out, that's y. And they said top slipping down, that's x. What's my given? Question, do you have to use x and y? No, use a and b, L and w. X and y is usually my go-to unless there's something else that's a little more obvious. Like volume and radius. Okay, given.
It's rate of 2 feet per second.
Okay, what's the rate? I'm going to write it down, 2 feet per second. But remember, kiddos, I want to, let's go back and look at that real quick. Rate. Where did I write down rate? Rate. I didn't. Let's write it right here. If they tell me a rate of something, and I'm assuming the rate is the derivative because they're not telling me average, like one time find the average between these two. They're just saying find the rate. That's a D. And if it's a real life scenario, not like an f of x, it's d something dt. So what rate are they talking about? Who's changing? What's changing? 2 feet per second, but what? dx dt. The distance from the, which we labeled x. So the rate of x. Why? Because it's a ladder slipping down. What's changing? Oh, this distance is changing. This distance is changing. How fast? 2 feet per second. What are they asking me to find? How fast? Rate. What's changing? dy dt. How fast the foot is moving. How fast this side is lengthening. Hold on. There's one thing we haven't thought about. Wait, such that? Wait, there's no R in the problem. Pause, does that make sense? Eyes up here, totally tuned in or else you're going to miss it. We have to know how to read the problems or else we're lost. Okay? Slipping down the wall, rate. Ooh, I labeled him x, dx dt. That's how fast it's changing. Find how fast it's slipping. Ooh, that's the horizontal, that's dy dt. Such that when the top is, that's my, plug in at the end. What am I missing? There's one thing I'm missing I didn't think about. I think I heard it. Huh? Relationship, we're going to do relationship next, Hunter. Hold on to that. Function, the equation, we're coming to that. There's something I did wrong. Something's wrong up here. It's a little something. What should be negative? What does it mean if a rate is negative? That amount is decreasing. What's going on with x? What's y doing? Increasing. So he hopefully is positive, but this one's a negative. I gotta put a there. Wait, but they didn't tell me. Well, they did. It's distance is decreasing, but they didn't say decreasing. Sorry. Okay. Relationship. Quite a few of you were like, yep, that's next, and you're right. So let's relate it. I'm going to shorten relationship to relate. We relate with an equation. So relate x and y. Well, that's easy. I have 13. So how do I relate x and y and I have 13? Pythagorean theorem. Even got the snap in action. Okay, so x squared plus y squared equals 13 squared. After I relate it, I differentiate it. Sure. Or rate it. Differentiate. Oh, there's not a rate in there. It's close. Related? I want the rates. I want the relationship of the rates, but I have to take the derivative.
No problem.
So relate it, relate the variables. Differentiate, then you'll see the relationship of the rates. Come on, cool kids. Let's see if you can do the implicit from yesterday. 2x dx dt plus dy dt, time is my independent, equals, what do you think one of the most common mistakes is if you're just going fast? Equals 169. I just dropped my pen. Equals 169. I was so excited. But remember, derivative of a constant is 0. People in this corner, what do you do next?
Set it equal. Right?
Oh, you don't even say it. Plug and chug it, right? Plug and chug. Thanks, Nita. Plug and chug. I was trying. Huh. Thank you. Plug and chug. Plug and chug what? What do I have? Totally have him, right?
Oh, we have that.
Bless you. Totally have him.
Whoa.
I have nothing else. I'm stuck. Impossible problem, go home. No, we want to solve it. Come on.
Find
How do I find y?
Pythagorean theorem.
Oh, wait. So if they give me something, they might not give me everything, but I can find the other thing I need. They give me 5. What's y? I don't know what it is, but I do know it's a right triangle, and if x is 5, guys, what's y?
Number 12.
12, yeah, 5, 12, 13, Pythagorean triple, or you could just plug it into the original relationship and say, psh, if I have the one, I can find the other. They're not always going to give you everything. They're not going to give you every single piece you need. A couple things you might have to go looking for, but you can find them. So with Pythagorean theorem, and with just plug and chugging what I have, I can plug in 5. I can plug in negative 2. If you're amazing and units are confusing, you might be plugging in units to try to help yourself out. Like, hey, x is feet. Dx dt is going to be negative 2 feet per second plus 2y. They didn't give it to me, but it's a right triangle, and I know 5. He's 12 feet. Dy dt, I'm missing. Could you have gotten dy dt by itself before plugging in? Sure, but you could just plug in lots of numbers and make your life easier. I have negative 20 added over. What's he end up being? Feet times feet per second? Y is, look at your picture. Y is this side. If I know 5 when I'm plugging in, if I know 5, I can find 12. And then I divide and I end up with dy dt. As long as the units are similar, I'm good. AKA, I have feet. Time is only measured in seconds. Once quantities become unsimilar, like radians in feet, things get a little messy. There's a couple ways of doing it. Dimensional analysis, I've showed you keeping in the units all the way along, and then they should work out, hey, divide by feet. Ooh, it's just feet per second now. 20 over 24, 5, 6. Feet per second. But guys, you can always double check, or if somehow you get lost in the units or the units lose you, could be both. Check your measurement. dy is measured in what? Y is measured in? Feet. Time is measured in seconds. If you have no units, say for an angle in the future that you might see today or maybe naturally occurring angles naturally have radians. They don't naturally have degrees. That's just a random throwing it out there. And I'm done. Positive, right? Is that good?
Yeah, wait, yeah.
Because it's increasing. Number next one. Now, guys, if you look at the very top of this, this is example 3, which means I pulled it from the examples in the book, and the examples in the book are the ones that they solved. So do you have to learn it from me? No. Could you learn it from the book? Yep. I'm just trying to make sure it makes sense. Now, in homework, guys, the homework very closely reflects the examples, both the ones I choose for examples and the ones that I choose for homework. But the AP can definitely expand, which is why we're having like an FRQ, maybe even a little bit multiple choice practice day tomorrow, seeing what else they do besides baseball diamonds and rockets and cameras and planes and missiles and ladders slipping down walls and balloons being blown up, although they like that one. They can do a lot more with related rates. I can't show you a lot because we still need to learn integrals, but I can kind of introduce it. So that's tomorrow. Today we're just seeing, okay, can you get the idea from a picture, and then can you, with a little bit different scenario, can you repeat the process in homework? All right. Question, what are some things I should label? Distance between? The bases? Okay. So distance between, is that changing, a variable, or constant, one number? Okay, distance between bases in this scenario is 90 feet. I know that. That stays the same. So if that's 90, that's 90. Oh, that's 90. Shh. Focus. Okay, what's something else I should label? Maybe something that's changing. I could label this side, but is that as helpful as labeling this one? That one doesn't really combine to make a shape, right? It's a trapezoid? Yeah, let's not go there. Instead of thinking about this side changing, let's think about this side. And guys, since they're literally this exact same thing, the runner is running along, so as he moves away from this one, he moves towards that one. These rates, besides this one being positive and that one being negative, they're the same magnitude, the same number. So, let's label him like X. And then what's something else they talk about besides second to third base? Second to third, I labeled him X because he's going to change as the runner comes. What else is changing? Distance from home. All right. Anything else they talk about? The line second to third, distance from home, between the bases. I think that's it. This one, you can name him the baseball problem, okay? Or baseball runner problem. And you can go to the picture labeling and go to given and find, and you didn't have to write any of that unless you really, really wanted to. Okay, given. What do we got?
90.
What about 90? The sides are 90. Well, we already, okay. True, sides are 90. We labeled it. What else are we given? dx dt. How do you know that? Second to third. Speed of, that's a rate, 30 feet per second. Now speed means absolute value, so what am I going to put for x if I'm thinking like velocity?
Positive.
If I think about specifically dx dt, his speed is 30, but if I'm talking about just his general rate, not absolute value of his rate, is it positive or negative? Positive?
Negative.
Negative? Why?
Because it's decreasing as you
It's decreasing. Negative, decreasing. Danny, where's your pencil? Where's your notes? Sterling, where's your notes? Where's your pencil? I'm not just putting on a show for my own enjoyment. Guys, I know you need to keep up, so just keep tracking, okay? Or catch up is what I meant, sorry, not keep up. What am I going to find? What am I going to find? I'm not finding distance between home is what variable? D what dt? dy dt, such that, what's my instant? 20 feet from third base. Got it. Baseball, he's in. Okay, relate it. Oh, just like the last one. What's the relationship? Relate it. I have Jessica. What's my relationship?
Squared equals x squared plus 90 squared.
Oh, y squared equals?
Yeah.
Okay. I'll just, since I accidentally wrote x squared. Okay. What's my next step, Josh? I can't yet because I don't have a, so what do? Yeah, implicit differentiation. And how do I do implicit differentiation? I take ddt. Good job, Benji. ddt. When I take ddt, Russell, what do I get?
2x dx over dt equals 2y.
Nice, because where'd that go? Yeah, that's 0. It goes away. 2y dy dt.
dy.
Good. Haley, what's next? Josh will help. Josh.
Plug and chug.
Plug and chug. Plug it in, plug it in. Everything you got. What do I have? X, I have that. That's 20, right? dx dt, that's...
30.
Ooh, what did I never do? Oops. Negative.
Oh, negative.
Rough. I know, I'm sorry. I apologize. If you're keeping in units, as long as they're similar, we're good. Equals... Uh-oh. Spaghetti-o, I'm done. I'm sunk. They didn't give it to me. I'm helpless. I can't do anything on my own.
Chunky poo.
Come on, what do I do? Yeah, Pythag. If I have 20, good parser, 20 squared plus 90 squared equals y squared. Square rooted. What's the square root of? 400 minus 8100. No calculators anywhere on word how to go, you guys. Emily's got it. Square root of, was I right? 400, 8100, 8500.
That's 36,
92 point 195. Technically, if I was you guys, would I have rounded that in my work? I would keep it as extensive as possible so that I don't introduce error. But that's just me. So maybe you keep in the square root of 8500, or maybe you have the decimal. But if you have the decimal, let it go out like maybe 6 or 9 digits, or just stow it away as a variable and then plug it in. dy dt is equal to 2 times 40 times negative 30 divided by 2 times 92.195. If I kept my units in, that would be feet. So I'd have feet squared per second over feet, that's feet per second, which should make sense. Got it. 2 times 20 times negative 30 divided by 2 times. The 2's cancel, 20 and 30 would be negative 600, 600 over the square root of 8500, whatever, we'll just stop. Does negative make sense? Why? You're getting closer to home, right? You're getting closer to home. That distance is decreasing. And I'm done. Good. Just the baseball, yeah. More sports analogies, huh? I don't know what excites period 1. Sorry. Well, you guys wouldn't want calculus period 1 either, right?
No.
I like it period 1, but like on Wednesdays, okay. Let's do something more exciting. Oh, that's boring. Let's do this one. Guys, this next one is an example. I'm not exactly sure how much time we have. I guess I should look on the board and figure it out. Oh my word.
We have like 14 minutes.
Okay. Let's go ahead. Since this one is, wait. This one's an example, right? So what's the book have?
Answer.
A solution to it, which we might peek at real quick tomorrow. because the book doesn't have an answer for it. And the one you have in homework is an extension of this problem. So let's check him out. Example number 4, I have full faith you can look in the book. You can, I don't know if you will, but you can, you should. Check it out. But we might peek at it a little bit tomorrow. But this one's not an example, no solution in the book. And in problem, I think 35, it says look back to 34. Make sure in homework you're solving the right one, or else you'll be very sad. You guys can read, right? Let's make them smaller. Oh, too small. Where'd he go? Ooh, I have a missile and a plane. Guys, this is exciting.
The plane's gonna crash.
Oh no, we're super.
Or an anti-aircraft missile, to be more
Why is the
specific.
plane gonna run into the air?
Well, the plane's not on purpose. The plane's going and someone just shot a missile and they're trying to intersect its path at. Okay. Well, if it's heat seeking, that's a little different, but
Just turn off.
maybe the plane's instruments are down. All right. What should we label? X? What should we label X? Okay. Dai is seeing that we have a given rate. We have miles per hour, and if you just start labeling stuff, well, we have to go to the picture and figure out what you just labeled, right? Question, what were they talking about when they said 600 miles per hour? Speed of the plane. So if I labeled him X, I need to label his distance changing X, right? What else looks important? Straight line. Perpendicular to the flight path. Oh, hey, that's the missile, right? So maybe he's important. Anything else? At the instant aircraft is flying at. Ooh, this is at an instant. Technically, it wouldn't be constant. I think I'll put that in my such that. But you're right. They did give me this. They did give me that and that. But this is all my when. At the instant. This is my such that. Technically, it's not constant. What are they asking for? Look, find your how. How rapidly is. What else should I label?
Oh, decrease.
D, Z, LMNOP? What do you want? Z. Okay. Constant speed, I labeled that. What's my find?
Fine.
Uh-huh.
How fast?
Well, the instance my when. That's my such that. What's my find?
Like,
DZDT. Good. How fast the distance between? Such that. Find how fast, how rapidly. Right? What's my such that? Aircraft is 2 miles from impact, so X equals.
2
What else?
Y equals 4.
What else?
Y.
DYDT. The missile is flying at a rate of something. 1,200 miles per hour. That's a little fast. Guess it has to, though, huh? I think I missed something. What did I miss? Yeah, because what's happening with those distances? They're decreasing, so technically he's a negative and he's a negative, right? Technically. Now, if we notice something at the end, if we answer like, ooh, it's decreasing at a rate of negative, we just double negative. I can't make that a verb either. We just made it a double negative, which means a positive, so be careful. If you say decreasing at a rate, you don't need the negative anymore. But we're doing our math. Relate it. Today's been way too easy. Every single relationship has been what? Man, it was boring. Tomorrow FRQs will be much more exciting.
Is that good?
Well, it's a little more exciting. Some of you might be getting bored right about now. Or
I'm not bored.
half an hour ago. That's okay. You're working on something else. Okay. equals z squared. Oh man, and all the other ones we had a number. Is that okay?
Oh, well.
That's okay. All right.
What?
We're going on faith, huh?
But yeah.
Obviously, our faith in our calculus book should not be the same as our faith in God, but you can usually trust that the problem they gave you is solvable.
No. Yeah.
Is that a word? 2x dx dt plus 2y dy dt plus 2z dz dt. You guys, zoom ahead and solve me this problem. You know what to do. Rate it. Not a 10, but a derivative. Then plug and chug. I don't want to zoom past some of you guys get a little bit head start. Remember, if you don't think you have it, I bet you have enough information to get it. Ooh, anybody see a problem?
-2. Oh, no, sorry.
Wait, never mind. Okay. I thought there was a problem. I thought it was given in feet, but that'd be pretty close if it was just 2 feet away.
Wait,
Never mind, 2 miles. There we go. We're okay. It's all in miles, but just be a heads up. If they give you one where like one is measured in feet per second and one is measured in miles or vice versa, you gotta convert. They have to be like terms. We don't have a problem. We're good. I thought it was different units, and sometimes they are, but this one's not. Y is 4. dy dt.
1200. Negative 1200.
What's the problem, kiddos?
Solve for
That you might think is really there when it's really not.
no.
Z! But it's the right triangle. If I have x, if I have y, I can find z. So the square root of 2 squared plus 4 squared, that's 4, that's 16, that's 20, that's 2 root 5. Am I really just hearing sure's? Anybody?
No, yeah.
So then multiply, divide, we got it.
Yeah, we got area.
What are my units going to be at the end? Without even...
Miles per...
I didn't keep any of them, did I? I was being lazy, but... Z is measured in miles, T is measured in hours. I'm pausing, you guys could do the rest. Josh, go ahead.
Why is it -600 because the plane is approaching?
Because the distance between the plane and the impact point is decreasing. And y is negative because that's decreasing, and z should be negative because that's decreasing. But if you answer with the word decreasing, let's say you're like explaining your answer. They say find it, explain it. They love to do that. They're like, ooh, the rate is decreasing at negative. You just made it increasing. So either say decreasing at a positive rate or is changing at a negative rate. But that's only if you're like putting it in a sentence. Nick?
You say increasing at a negative rate.
Technically, yes. But if you really want to play tricks with your AP graders' minds.
But then play tricks on us.
I got the answer.
You usually don't want to mess with someone who is giving you a grade.
I got the answer.
Wait a minute.
I got the answer.
Anyway,
I got
what
the
do we get as our answer?
I got it right here.
What is it, Benji?
Negative 1341.
1341. Someone back him up.
0.6.
0.6. Someone back him up.
C.
Sweet. Negative 1341. Wait a minute. We always do 3 decimal places at least.
641.
641.
641.
Now, guys, technically on the AP is super random, but I'm just saying it now. They allow you to round the third or truncate the third, which means you could just like put 3 and stop, or you could put 3 and round the third one. But no matter what, have at least 3. And if you want, if you're like, I never want to make a mistake, you can write 6 every time. You just don't need to write 6 decimal places. They make sure that you have 3. Benji, go ahead.
So on the AP exam, like, can you run it to 1 decimal place or have to be at least 3?
They'll mark it wrong.
Really?
Not the whole thing. for that part they want.
So I'll be at least 3.
It's AP standard, you have to have at least 3.
Okay.
Whether you round it, whether you truncate it, you have to have at least 3. I'm just gonna quickly zoom ahead. Ooh. To an FRQ from AP number 9.
Oh, do it from.
It's the third FRQ on AP number 9. Ooh, I got some interest. Okay, so ready? Part C. Now I'm not just solving the whole thing for you. And there's some, but part C. Why am I super interested in this lesson at this part on part C?
Rate of change.
Indicate units of.
Air temperature is a constant. Wind velocity. Wait, wind velocity. That sounds a bit like a rate. Is 20 miles per hour. If the wind velocity increases at, oh man, that just got confusing. dV dt. Oh. If wind velocity increases at a constant rate, dV dt is 5 miles per hour 5 miles per hour squared, whatever. What is the rate of, hey, do you see a given right here?
Kind of.
Do you see a find? What's my given? Hold on, what did they name velocity? Is there a name for it up here somewhere? V. V. Is that velocity? Yeah, velocity is V. So given wind velocity, given dV dt, thank you, 5 miles per hour. What's my find? What is the rate of change of the wind chill? What's his variable? They gave it to me, I have to use it. Wind chill, W, right? So find dW dt such that ooh, interesting. What's my relationship? What relates V with W? So if that's my relate, that's my relationship. Just a hint, all the decimals, yeah, this is totally a calculator one, I forgot. No, I wrote it on there, right, calculator?
Yes.
I need to rate it, right? Okay, I'm not gonna keep going, but I do wanna ask a question. We're gonna come up against a little bit of a roadblock. dW dt, cool. dV dt, cool. V, cool. How do I plug in for V if I have T? No, wait, we already knew that. Well, can we use that? If velocity starts at 20, could I make like a little off to the side how velocity and time are related? If velocity starts at 20 and increases at 5 miles per hour, he's going to increase 5 every what? Oh, well, that would be nicer. Because I can plug in 3 and then I can figure out velocity and I can plug into that. All right, just super random, gave you a couple hints. Oh my word, we're doing so much today, we're pausing. Pep rally is next, go support all your athletes. Stay super in tune the entire time, some exciting things will happen.
Free food?
And there we go. Let's go, honey, I don't.
I don't care.
Like anyone stays tuned in.
I'm gonna be tuned in for the video.
During my year we did.
Well, one pep rally.
We had cheers and everyone was cheer and they found the cup and
I relinquished my couch a while ago. That's cool.
you relinquish it for one day.
Yeah,
It's too
was that
late,
the
the
one